Welcome students. In this video, we are going to find the solutions of this equation. As you people can see, this is an equation involving logarithm functions and modulus function with say n plus 1 variables. See x, x1, x2, xn, there are n plus 1 variables. And we have to find the solutions, all positive real solutions. So what I can do is I have to use some properties of logarithms and modulus functions to solve this kind of problems. So what I can do, I will state a property of modulus function first. If we have two numbers a and b, then modulus of a plus modulus of b, right? It is always greater than mod of what? A minus b, right? I hope you all agree with this case, right? Take two numbers 5, a equals to 5 and b equals to 3. See 5 plus 3 8 and 5 minus 3 is 2. It will always satisfy no matter what. So we are going to use this property of modulus function in the solution of this case. Now look closely at this equation. This is a term involving x, x1, and this is a term involving x and x1. So we are going to punch it together in case of our solution. So if I punch these two terms together, that is like this: log of x x1 plus log of x divided by x1. See mod a plus mod b, then it must be greater than equals to this minus this, like this. Now we have to use the property of logarithms. If I use the property of logarithm, this thing becomes log of x plus log of x1, and this thing becomes log of x minus log of x1, right? So if I do some little adjustments, then you people can see the log x and log x terms will cancel out each other, and we will result simply like this. So if we couple two terms, that is log x x1 and log x by x1, we left with these things, and this term is simply greater than this term. So I can say the whole LHS is greater than or equals to, there is equals to part, greater than or equals to these terms. See, take 2 common, and log x1, there is a modulus part, log x2, and similarly log of xn. On the right hand side, what have we have? On the right hand side we have this thing, right? But the whole sum is in the modulus, and in this case the sums are separated. but we can adjust it with our similar modulus properties, right? The our right hand side is similarly is less than, because we know that it is always less than as per the generalized version of triangle inequality. The RHS is always less than or equals to this thing. I can say this because it is the generalized version of the triangle inequality. See, it is always the generalized version of the triangle inequality, that if you put mod A plus B plus say Z, then it is less equals to mod A plus mod B plus mod Z. It is the generalized version of triangle inequality, and so for that reason we can say it. But for the solution, we need to have these two things equals to each other. And for that equality, we must have individual terms equals to 0, because one is greater than and one is less than. For the solution, we must have both things equal. And if both things are equal, then we must have the equality represents us like this: log x1 equals to log x2 equals to all those things 0. Obviously, it will include that. Similarly, equals to 0. If equals to 0, then it simply means that when log is 0 when basis 1, that is x1 equals to x2 equals to all xn equals to 1. So we found all the xn's, but we haven't found the x. See, we don't need the value of x because x simply cancels out each other. So irrespective the value of x, we can solve this problem in this way. You can find the values of x1 to xn. If you like this video, please do like, share and subscribe, and do support us. Thank you.